You're good. Just drop that on my desk. I'll make sure it gets in the system right. Thank you, dear. All right. So end behavior. This is when we're describing our arrows. Not that one. That one. So we need one for my left arrow. Ooh, chunky pen. One for my left arrow, and I need one for my right arrow. So how do I describe my left arrow? As x goes to negative infinity, as x approaches negative infinity, what happens to my f of x, my function, my y? F of x approaches positive infinity. You can also call it y. It genuinely does not matter to me. So that's left arrow points up. That's what that means. How do I describe my right arrow? Gorgeous. Approaches positive infinity. Fantastic. Excellent work. So as x approaches positive infinity, as x gets really, really big to the right, my y's are going up. They're approaching positive infinity. So it's all about that relationship between my x and my y. So for my right-hand graph, now I've got a left arrow and a right arrow. And they're very similar. In fact, my right arrows are identical. Both right arrows point up. So my right arrow is going to be exactly the same as it was for graph 1. So my left arrow is a little bit different. As x approaches negative infinity, what happens to my y? It also approaches negative infinity because it's going down. As my x's get really, really small, my y's get really, really small. As x's go to the left, y goes down. And then for my right arrow, as x goes to the right, my y goes up. So as x approaches positive infinity, my y approaches positive infinity. So we will see end behavior again. We will use it when we get into our chapters on polynomials, which are the things that look like those equations at the top. By the end of the year, you'll be able to graph those. These are going to be super duper awesome and have great skills. Okay, the questions in our end behavior. Awesome sauce. So yesterday we did some kind of loosey-goosey getting the vibes of the graphs. Like we had a lot of information, but there was a lot of creative freedom in where we were drawing things. Today we're getting out of the creative freedom part. We're getting back into the proper answer part. But it's not going to be super duper crazy wiggly swigglies. We're going to look at some lines. We're going to go back through how to graph lines. And I mentioned it yesterday, but I really want to stress it. You have to graph in pencil. Please graph in pencil. Like, it's hard enough for you to understand when we cross out like equations and stuff we're working on and we follow that. If we're crossing out on a graph and we try to figure out which line we meant, which ones we're crossing out. Whew. Okay, so graph in pencil. And go all the way from wall to wall on whatever graph we have. And today, honestly, shouldn't really be anything new. You've seen these before. It may have been a minute, but we've seen these before. We've graphed lines before. You did that number one. You did. Was the thing. So I have up here kind of the 3 most common techniques we have for graphing lines. I am not saying this is our only options, but these are the 3 most common ways, and I'm going to show you these 3 ways today and how we would know when we want to pick one of these, when we might like one better than the other. So option 1 would be finding x and y intercepts. We're going to do this a lot of times when we're in standard form. So if we have an equation that looks like that ax plus by equals c. I'm not saying you can only use it here, but I'm saying we most frequently use it here, especially when c is a number. Like if it's a 0, it makes things weird. But if we got a number there, this is an easy way to do it. And to find my x-intercept, remind me, what is our x-intercept? What is the x-intercept? Where is it? It's on our horizontal line, right? It's where it crosses our x-axis. So it has a y of 0. So we substitute in 0 for y. And solve. It'll give us the point x, 0, our x-intercept. We will do the same exact thing to get our y-intercept, but just for the other letter, because our y-intercept is on our y-axis. So if we want to find our y-intercept, we're going to substitute 0 in for x to solve. And that'll give us 0, y, our y-intercept. I want to clarify, these are two separate solvings. So you can start from the equation twice. Two solvings. I have a lot of people that wind up trying to do them both at the same time, and it winds up messing everything up. Okay, so this is two solving to get to our x and y intercepts. But that's all we necessarily need to have to make a graph. Ideally, we'd like more points, but 2 is enough for a line. Another option is to solve it into slope-intercept form, or if we're given it in slope-intercept form. To get it in slope-intercept form, we need to get y by itself. So that's the whole goal. Get y by itself. And then it's going to look like y equals mx plus b. We've said that before. We came up with that when we were talking about our linear versus nonlinear. But what do the m and the b mean again? It's called slope-intercept form, so that's going to give us a little bit of a clue. What does m stand for? Slope. The m is our slope. How do we use slope? How does that help me? Rise over run. This is how it moves. Rise over run. What does the b stand for? It's our y-intercept. And the point will be our 0, b. It's the same exact thing, y-intercept. It's just added on the end. So make sure we watch out for the signs, but other than that, that's how we use it. And then probably the most, it's the less calculatory, but the longest in time of working is like a guess and check table, where we draw a table, which I'm going to put this over here because I need more space, like this, where we pick some x's to find some y's, and you pick things until you find places that's going to be on the graph paper I give you. So we would say, all right, maybe we want to know what happens when x is -2. We want to know what happens when x is 1. Want to know what happens when x is 10. I very rarely give you a graph that big, but you might. and you're going to substitute it in. So this one has a lot more substitution, but if you don't know where to start, it's a fine way to go. It works. It's just going to take you a while, especially if our intercepts are like way high or way low, to figure out where we are going to be on the graph. Okay, so we pick x's by the vibes or by intuition and substitute in. So that one I think has the most calculations, but most of them are typed into the calculator style calculations. So I tend to not use the guess and check table as much, but it is an absolutely valid strategy. Okay, and then we're going to practice, and I'm going to use all three of these today. We're doing 3 graphs, so I'm going to actually do a couple of them for a couple of them, just so we see that they all do the same thing. So we're going to make 3 graphs today, which means naturally, I have graphs for you. They're the same graphs as yesterday, but that's okay. It's the same thing. All right, so we are just dropping some lines. So you are going to make 3 graphs. And again, you don't have to cut them apart. If you do cut them apart, please make sure you pick up your own trash. We have classes taking tests today, so it's really like it's not. You're going to be in for a mess. All right, so here's our first one. So our first line is x plus 3y equals 0. And you can approach these with any of those options that we have. Some of them are going to work better than others. In this one, because it's set equal to 0 and not some other number, if we try and do our x and y intercepts, we're going to find it not super helpful because they're both 0, 0, so it's not enough information to graph the line. So if we have a standard form set equal to 0, don't go for your x and y intercepts. So we can either solve this to get y by itself or do kind of a guess and check table. So I'm going to do the table first, and then we can solve into the y equals just so we can see what that's like as well. So when we do a table, so this was our third option that I do not use super frequently. Before you water past me. There you go. All right, so when we're doing some sort of guess and check table, we're going to pick points either for x or for y and then substitute them in. So I want to pick some values to kind of test some stuff out. What values could we use for x? I mean, we can always start with 0. If I take my original equation and substitute in that 0, we're going to have 0 plus 3 times something equals 0. Right? See that substituting in? Well, 0 plus 3y, that's the same thing as just saying 3y. So what will our y equal? 0. Divide both sides by 3, and we get y equals 0. So from that first substitution right there, I know I have a point right here. I need at least a few more points. So what's another thing we could substitute in for x? Negative 3? If we when we are doing a guess and check table, we can pick anything we want. I could pick negative 100. It would not be super helpful because my graph doesn't go that big. So I would recommend sticking in the graph I give you because I'm going to go with 95% of the time good at making sure our graphs fit on our graphs that I give you properly. I've gotten better at it, but like it can occasionally happen. I'm not going to guarantee. But almost always it fits on the graph I give you. So it is a safe bet to use the numbers that are on our axes that are there. So when we're doing kind of a guess and check table, we are guessing, blind guessing, and just checking stuff out. So minus 3 plus 3y equals 0. So if we add 3 to both sides, it's going to give me that 3y equals 3. And I'm going to write that down because I feel like we need that written down. Plus 3. Plus 3. So I added 3 to both sides. Now we're going to divide both sides by 3. And we get that our y is going to equal 1. So we're going to have a point at negative 3, positive 1. And we can start to kind of see this line and see what it's going to start to look like. These guess and check tables I don't do super often because they have a lot of calculation. Like I'm going to have to keep doing this more times to get more points. Because we don't just graph with 2 points, we do as many points as we can. So instead of me continuing to fill in values, I'm going to go ahead and solve this now to get my slope-intercept form. So I'm like, this is a lot of work. I don't want to do this. So it's okay to change your mind in the middle. X plus 3y equals 0. I'm going to solve this now and put it in slope-intercept form, which means I want to have my y by himself. What do I need to do to get my y all by himself? Minus x from both sides. That's going to give me 3y equals negative x, or 0 minus x. So the opposite of x. What do I do to get y by itself? Divide by 3. I'm going to change the view real quick, just because I'm going to give myself a little more space. So if I divide both sides by 3, we're going to have our y equals when we have something like a minus x, sometimes it's really helpful to put the 1 in there. Because if we have 1x or if we have minus 1x, it's not always easy to spot that m. Because what is our m? Negative 1/3. So we have negative 1/3 x plus 0. What's up? I say, where did I lose you? I know we blinked and teleported. Okay. So we can still use our information from our table. I can use those points. Those points are valid. But instead of me substituting in a whole lot more x values and getting ucky things, I'm going to use my slope, my rise over run, my negative 1/3. When I am moving from some point with a slope of negative 1/3, how am I going to move specifically? Down 1, right 3. Absolutely valid. Let me get the chunkier marker. So down 1, right 3. I can do that again. Down 1, right 3. We could also go up 1, left 3. As long as I do at least one negative, I could go up 1 and left 3. That's still on that line. When we're graphing lines, I want you to give me as many points as you can. The more points you plot, the one easier it is to draw your line, and the more accurate your line will be. So when we're connecting up our dots, you're going to use a ruler. There are rulers in the boxes. I put them in there last night. If there's not enough rulers, or if you want more, if you want the longer ruler, because the long rulers do not fit in the boxes, Surfing Cat holds rulers. So you're going to connect them up. We are going to use a line. So use your ruler, because you're in lines truthfully. And we are going to go from dot to dot. And then they have arrows on both ends because we only stopped because we ran out of graph, not because my math stopped. I could keep going. I could do -7, I could do -10, I could do -100. Same thing with the positives. I could do +7, I could do +20, I could do +5 million. We only stopped because we ran out of graph. And you do not have to use more than one technique like this, but when we start with a table, sometimes the amount of calculations get a little overwhelming, and I'm like, I really don't want to have to do that. Super gross. So I will not use tables very frequently at all. But it's a valid starting strategy. So if you're not sure where to go, it's a place to start. But that's our line. That's what we're doing with it. Random question I'm going to throw at you. What's our domain for this line? That would be an intercept. What's our domain? Negative infinity to positive infinity. What's our range? That's our smallest y's, negative infinity. It is going down. It's going over a lot faster, but it is going down. So from negative infinity to positive infinity. And in fact, every single line, aside from horizontals, will have this exact domain and range. The only ones that don't have this are the straight up sideways. Every single line will have that domain and range. Which is handy. I just wanted to touch on that because I know that's a struggle point for us. So we're going to just occasionally touch on domain and range. Randomly. All right. Let's do another one. So I've got 3x minus 2y equals -12. And so what I'm going to do with this one is I'm going to do our x and y intercept version. Because it's still substituting in, but it's less gross. And we don't usually mind substituting zeros so much because we love when 0 multiplies with things. Makes things really handy. So, I'm going to make sure I do that. There we go. So to find my x-intercept, I don't know why I keep doing that as an arrow today. That's just like a weird vibe. We're going to wind up with a point that says x comma 0. That's what x-intercepts look like. So we are going to substitute in y equals 0. So I'm going to take my equation, my 3x minus 2 times 0 equals -12. Substituting in that 0 for y. What is 2 times 0? 0. So this is the same thing as saying 3x, that's an x, minus 0 equals negative 12. Well, that's just the same thing as saying 3x equals negative 12. Because minus 0 doesn't change anything. So now we can divide both sides by 3. I hear a couple of us spotting it already. My x equals negative 4. So my x-intercept is at negative 4, comma, 0. When you guys are doing this work, you do not have to write this many steps if you don't need it for your brain. I will write all the steps up here written out, just because for some people that is really, really helpful. But if you don't need to write the substituting in 0 and then the multiplying to 0 and then the dropping it out, you don't have to. Okay, so if your brain can do it skipping steps, I'm 100% okay with that. But 1 point is not enough for us to get a line, so we need to do the other one. We need our y-intercept as well, which is the very similar vibe. But this time, whoa, wrong pen. To get my y-intercept, which is going to be the point 0, comma, y, we substitute in our 0 for the x. So we're going to have 3 times 0 minus 2y equals negative 12. So what's 3 times 0? 0. So 0 minus 2y. Again, I'm just writing out every step. If you can get straight here from that first substitution, I'm 100% okay with that. So what do we do to get y by itself? Divide by negative 2. So what is my y-intercept? 6. So we have the point 0, comma, 6. Which is way up here. When we are finding our x and y intercepts, that is enough information to get us our line. We don't have to fill in the spaces to get more points because this technique doesn't give us that option. Okay, so if we're working with slope-intercept form, I want as many dots as we can, but with our x and y intercepts, 2 is okay. So again, using a ruler, connect up your dots, arrows on both ends. Go from edge to edge on your graph paper. Always do as much as you can on the graph. Do not give me lines that are this big. I cannot tell where your line is going if it is molecular level. I always have someone that'll get like x-intercept, y-intercept, and will just give me this. Like, I can't see what you did. Do not give me itty bitty baby lines. Big lines. We are big kids, give me big lines. Okay? Do not give teeny tiny baby lines. Boop, boop. That's what our line should look like. One more graph, okay? Questions on this one before I change page? Coolio. Last one. And look at that. I gave it to us in our slope-intercept form. Oh my God. Look at me being nice. So when we're using our slope-intercept form, it's really handy to write those pieces down. So what is my m? What is my slope? 3 over 2. Remember, that's my rise over my run. What is my b? Negative 4. Watch that sign right there. Because this is my intercept. This is called slope-intercept form. That's my intercept. Is that my x-intercept or my y-intercept?
Y. Your B is your Y.
B is our y-intercept. And an easy way to kind of spot that is to think about if we did x, y intercepts, and I substituted in a 0 for x to get my y-intercept. If I substitute in a 0 right here, 3/2 times 0 is just 0. Y equals -4. That's my y-intercept. Okay, so it's built in right there. So this is my y-intercept. So this leads us to the point 0, -4. So that's where we start. You start at your y-intercept. What's up? Yep, starting at -4. Up 3, right 2. And I'm going to draw that just so we can see. Up 1, 2, 3, right 1, 2. So that's how we're getting here. Up 3, you can do it again. Up 1, 2, 3, right 1, 2. And you do not have to draw the arrows if those do not help you. And I can do another one. Up 3, right 2. Up here, as many dots as we can fit. If we had enough space, I could go the other direction and go down 3. 1, 2, 3, left 1, 2. But it's off my graph, so we don't need to do that. But we can absolutely do that. I can go the other direction as long as I only flip 1. So we're going to connect them up using a ruler. I finally figured out a way I can make my iPad let me use a ruler. Kind of. It's better than when I freehand it. Lines need rulers. If you are freehanding a line, especially when it comes time for like a quiz, there will be points taken off. It's important. Rulers for lines. Super duper important. Because eventually, we're going to take more than one line and put them on the same graph and talk about where they cross. So having lines be super duper accurate is really important when we move forward. Okay? So I know it feels like I'm being petty on that one, but I promise it's important. Rulers for lines, rulers for lines, rulers for lines. Not optional. Okay? Questions on our lines? Should have hopefully been reviewed, like we've seen these before. But I know it's been a minute since we did that properly. You guys have a solid 5 minutes. Homework 5, which has not been passed out yet. I just have this one. Is the last one before our quiz next week. So we have a quiz on Thursday next week. So this is also what we're going to talk about on Monday. So there are 3 graphs of lines on here, and review question and review question, but there's 4 things on here that we haven't talked about yet, and we're going to look at inequalities on Monday. So if you're still finishing up homework 1-4, that's fine. I'm going to pass out 1-5 anyway. So you can have it. Work on it.
We're turning in our bell.
And yes, turn in your bell work today. It is week 5. Turn it in. That way you don't have to keep track of it. Because I know I give you a bunch of papers. Okay, so our quiz is next Thursday. And it's going to be over all of our x-intercepts, domain and range, all those things that we've done, including the sketching and including our lines and inequalities. Okay, I do have a review for you, but we're going to have 2 days for review. If you're one of those people that likes to work over the weekend on review packets, I have it, but you don't have to have it. But if you wanted, I have it over here. me update our date because I haven't done that yet. Where'd the eraser go?
What are you?
My big erase?
Right
There's one over there. There's also supposed to be one over here. I'm supposed to put in my bucket. That's not a everybody eraser. That's a my eraser. So we're on 6. Oh, and look at that. We're down to 20 days till fall break. School days, but 20 school days. I like that 20. 20 more school days till fall break. We can do that. That's 4 weeks.
I'm going to Arizona.
Ooh, that'll be